Dzień dobry and hello. In this lesson, you will learn about error handling. In the real world, your code will almost always encounter some sort of error. Errors will automatically stop your code, thus stymie the rest of your code from executing. So in this case, the first thing that we want to do is fix this error and rerun our code. But what if the error is caused by something transient, something irrelevant, or something external that you have no control over? This is where error handling comes in. Error handling is composed of three main statements which work together: try, except, and finally. So try essentially is used to ensconce any sort of code that you're interested in that may potentially fail by throwing an error. So for instance here, we are going to declare a list variable, and it will be a bunch of numbers, after which we will print out one of our items. And we will print out the fifth item. So when a program fails, it will throw some type of exception. There are many exception types, and the most common built-in exception types can be seen in the snippets below this video. It is the developer's responsibility to choose the correct exception type when using the except statement. For instance, if we want to specifically catch index errors, we need to specify that. If a matching exception type is caught in the try statement, it will execute a block of code within except. So right here, for instance, we can say something like print index is out of bounds. And then we can show the length of our actual array. And it will pretend like nothing happened by continuing on with the code after a try except finally code. So we can add a print statement here saying everything is done. The finally statement simply runs the block of code in it regardless if our code catches an exception. This statement is optional. This means that to catch errors, we only need the try and except statements. So let us run our code and see what happens. And we can see, since we don't actually have this many items in our list, we get an index out of bounds error, which we successfully catch in our except statement, since we specify index error, thus printing out our line right here. And notice how this is highlighted in PyCharm. Although it says it cannot be defined, we are finding it just fine over here. And this is because we're not using the best practices. In best practices, we should declare any sort of common variable up here, thus make PyCharm and other professional developers happy. We can also specify multiple types of exceptions using except all at once, as such. So we can put it in brackets, and we can say, for instance, we also want to catch value errors and assertion errors, or any other type of errors. You can put as many as you want in here. But what if we have an error that's not listed in our except, right? So for instance, if we know we're gonna get an index error, but we remove index error and we run our code, simply what happens is the error happens and we don't successfully catch it. We can also specify a general exception, which will pretty much catch every kind of error. Now, this is highly not recommended in the real world, as you will make many people very unhappy, including yourself, due to the large amount of bugs that this will raise. So let us clean up our code by bringing back our index error for being caught, and we'll add a final print statement that simply shows the last item in our list. Right, something like that. So let's run it. And we can see everything looks great with no uncaught errors. Lastly, as developers, we can invoke errors using the raise function. So say we have some sort of variable called celos equal to 4, and we'll say if this is not equal to 0, then we will raise a value error. Now we can specify any kind of error, but we are choosing to use value error, and we can put in any message that we want to display to our users. So cannot be a value other than 0, right? So if we run this code, we can see we get a value error because we gave it. So if we change this to something like 4 and have 4 be right here, then no error, no problem. Fantastic. You can now handle errors in your code, whether they may be expected or unexpected. With this new skill set, you can develop safeguarded code desirable by pretty much all software companies. How amazing is that? In the next lesson, you will learn about functions. They will save you a lot of time.